Hey, folks, welcome to a new series I'm going to create here. Um, my other project I've been working on is in a place where there's a lot of complex things I need to do, and it's not really, doesn't really lend itself well to recording because I'm working on trial and error fixes to certain things, and it's just takes a long time, and it's not really worth watching. So I've had a bunch of people talk to me about um, C++, and a lot of people that I think know blueprints pretty well, but are hesitant to delve into C++ and would like something a little bit more basic to show how C++ works and how I use it. And so I thought I'd create some sort of, I guess we'll call it a RPG. Um, Something a little bit more simple to demonstrate, um, you know, the C++ workflow and how I use it. So I'm going to create a new project here. Um, and I always start with a blank project, C++. If I need assets from these other, like if I need the third person mannequin, which I probably will at some point, what I typically do is I create I create a project from this third person template, and then I'll grab the mannequin from there and migrate it into my project. I do that because I don't like the structure that these templates create, so I prefer to create my own structure. So I just start with a completely blank project, C++. I typically do not include the starter content, but I'm going to this time because I'm going to use parts of it to demonstrate some simple C++ logic. When I create a project, I always come up with some kind of code name, 5 or 6 characters tops. Usually I don't want to go more than 6 characters because I use the name of my project as a prefix for everything I create. And if I create some really long project name, then that would get unwieldy really fast. It already tends to get a little unwieldy anyway. But if I had a long project name, it'd be really bad. So I'm going to call this one, I don't know, I'll call it Badger. And I'll go ahead and hit the create button here. This is going to create my C++ project structure with, and it's going to launch it in the IDE that I use. I'll talk about that in a second. And it's going to open up the Unreal editor with the default map, which is actually an open world type map that uses I think it's like the newer like world composition feature, which might be interesting actually at some point. The IDE that I use to edit C++ code is the Writer IDE. I actually pay for a license for it because I use it in my in my day job. I'm a contractor. I do a lot of C# work, and I prefer the Writer IDE. So I think my work gives me a license, a Visual Studio license for VS Enterprise, but I just prefer the Writer IDE, so I buy my own license for it. Although if I asked, I could probably get a license from work, but it's really not expensive, $15 a month. So I earn a lot of money on it, so I don't mind paying $15 a month. But as of now, the Writer IDE is now free for non-commercial use. So if you are, a hobby developer, if you're not planning on releasing anything, just like me, I'm not releasing. I'm not planning on releasing any game out onto Steam or anything like that. I do this because I like to code, keep myself sharp in some of my off hours, and this is more interesting than coding some business system. So if you're like me and you're just doing it as a hobby, you can now download the Writer IDE for free, and I would suggest doing it because the Writer IDE, I think, is still at this time, I think it's still better for Unreal development than Visual Studio. Visual Studio has gotten loads better than it was just even 6 months ago. And it's really a decent option now, especially if you if it runs well on your machine. I find on this machine, Rider runs a lot better for me for whatever reason. But anyway, it's worth checking out both IDEs and seeing which one you like. I prefer Rider. Rider's now free, so you can go and download it and use it to your heart's content. I'm going to pause the recording now while I wait for this for the source code to compile and the editor to launch. Okay, so it's all finished up. My editor's launched. One thing I do want to show is in the editor preferences window. If I come down to source code, you can see my source code editor is set to Rider uProject. I believe this defaults to Visual Studio 2022. So I had to come in here and change this before I created that project so that it would open in Rider. That's just something to be aware of. If you're using Rider, you'll have to change this, and you can actually choose either one of these. If you use Rider, it opens the solution file. If you use Rider uProject, it opens the uProject file. I don't even really know the difference here because the linking between Rider and Unreal seems to work properly regardless of which one I pick. But anyway, it's set to Rider uProject. It's something I wanted to point out. What I wanted to do before, in this first video, before I get into creating anything, real, first, what I do want to say is the very first thing I do in any project is I come into this content folder and I create a new folder inside of that called app. And this is where I'm going to put all of my content. Anything I create is going to be in this app folder. That just helps me keep my work separate from, the content that I bring in from the marketplace or from plugins or whatever. In this case, the starter content's there. I'm going to create a new folder inside of app called maps. And I'm going to hit the save button so that this default map, I'm going to store it in app maps. I'm going to just call it test map for now. I'm going to save that. And I thought what I would do is just demonstrate the simplest thing I could think to do in Blueprints and in C++ to show just how similar they really are. Because at the end of the day, if you already know Blueprints, the reality is Blueprints and C++ are very similar. Really, all you need to learn is the basic C++ syntax. So really, you could watch some beginner C++ videos and watch, learn about variables, functions, classes, and interfaces, and learn about how classes work and how inheritance works, where you inherit other classes. The reality is if you're using Blueprints, you already understand inheritance a little bit, because when you create a blueprint, you're inheriting from a C++ class or another blueprint, but typically you're inheriting from something like actor or pawn, character. Those are all C++ classes, and your blueprint is just inheriting from them. So you already understand inheritance, to a certain extent. So learn. That's really all you need to learn. Is you probably want to understand a little bit about what pointers are, but even that is not really that big of a deal. Writing Unreal C++ is a lot different and a lot less complex than writing, other types of C++. You don't have to worry about memory management because the Unreal garbage collector will take care of memory management for you. you don't have to worry too much about pointers. You maybe just need to understand what they are, but even then, it's not strictly necessary, since Unreal sort of hides that from you, the complexity of that from you with some of the generic classes they've created. I guess you do want to potentially just understand a little bit what generics are, because the Unreal API uses generics all over the place. So it pays to know a little bit about those. If you happen to know C Sharp, you really know everything you need to know in order to write Unreal Engine code in C++, because really writing Unreal Engine C++ is very similar to C Sharp because of the way that the Unreal Engine works. Anyway, let's get into something like super, super simple. For now, I've just got this app folder. I'm going to create a blueprint in it. Like I said, so I'm going to inherit from actor. What I want to do is I'll just create some object that spins, that rotates every frame, as a simple example. So I'm going to inherit from, this blueprint is going to inherit from the actor class, which is a class that's a part of the Unreal Engine core API. So I'm going to do BP underscore, and like I said, I prefix everything with the code name of the project. So it's going to be Badger underscore, I'll just say test. So we'll open this blueprint, and let me dock it in the main window. And save it. So if you know anything about blueprints, the way you add functionality to an object in Unreal Engine is you add a component to it. And I'm going to add a static mesh component so that we can use a mesh to give some visual representation. So I have this static mesh component. I'm going to come over here, and in the static mesh property, I'm going to set it to, see what we got here in the starter content. I guess this pyramid will work. So I'm going to save that. I'm going to come back to my map. I'm going to take that blueprint and I'm going to drop it right in the world there. And now if I run, I can see the pyramid is just sitting there. It's not doing anything right now. So let's make it do something. I'm going to make it rotate on every frame. And when I create a blueprint, come into the event graph, I get rid of everything that's in here by default. So since we want something to happen on every frame, we want to override the tick function. And this is basically just the underlying actor has a tick function on it, and we're saying we're not going to call that tick function, call our tick function instead. When the engine calls, at the root of the engine, there's a big loop that loops through every object in the world and calls the tick function on it. Every actor in the world and calls the tick function on it. So during this tick function, actually, before we get into that, let me also create a variable. I'm going to create a variable and call it rotate speed, and we're going to make it a float, which is just a number with a decimal component. And compile. Now that it's compiled, I can set a default value. I'm just going to use 2. So 2.0 is our default value for the rotate speed of our object. So I'm going to come down here, right click and say get actor rotation. I'm going to right click on this pin and split this pin out into the individual components. I'm going to grab the yaw and I'm going to hit the plus key to find this add function. In the add function, I'm going to add the current yaw of the object. I'm going to add rotate speed to it. So I'm going to get rotate speed, drag it out here, put it in this other node. That's going to add these two things together. Then I'm going to right click over here and look for a node called make rotator. So that creates a new rotator object. I'm going to take the yaw that I created from this addition operation and put it right in here. And so now I've got a rotator that has an updated rotation. I'm going to drag off of here, say set actor rotation. I'm going to take this and drag it right in there. That's basically the simplest blueprint I could think of to demonstrate something. So I'm going to compile that and run. And this time let me drag over my run window. Now you can see the pyramid sitting there rotating. So that was nice and easy to do. If you're familiar with blueprints, that's not going to be anything like that's the most basic of basic blueprints you can imagine. So let me save that, and I save a lot, because if you don't, sometimes this editor, especially when you're messing around with live coding, which we'll demonstrate probably in a little bit, it can get a little sometimes iffy. It likes to crash a lot, and so I save constantly. So now we've got that basic blueprint. Let me demonstrate that exact same thing in C++. So if we come into our project that was created in the games folder here, you can see Badger, and come down to source, and again Badger. This is basically our root folder that we're going to put all of our source code in. And this is the these classes don't really do anything. They're not worth looking at. So I'm going to right click here, and this is one thing I like about Rider, is it comes out of the box with the ability to create Unreal classes, which are formatted a certain way. Basically, it's got templates for creating Unreal classes. Visual Studio, for using that, there are plugins you can find that'll do the same thing. So I would go looking for one if you're using Visual Studio. So I'm going to create a class, and again, I prefix with my code name. So Badger, and we'll just call this test actor. And we're going to inherit from actor, just like we did in the blueprint. There's a couple of options here for base folder. One is root. If you do that, it'll put it right here in this Badger folder. I don't like that. So my other two options are private, in which case it puts everything under a private folder. If you choose public, it's going to use, you can see right here, it's going to create a private folder. It's going to put your C++ file in that private folder. It's going to create a public folder and put your header file in the public folder. What this is really for is for like reusable code modules, which I am not building. A lot of people I've noticed that do C++ do this. They use this public private structure anyway, even if they're not writing reusable modules. I guess that's a personal preference thing. I prefer everything to be in this private folder. I don't like my header and C++ files to be separated out. So I choose private, I hit OK. That's going to add my new class, my new header and C++ file. And the first thing I always do is I appreciate comments in code. I think you should comment your code everywhere where it's necessary. These comments here are completely unnecessary. I understand what the tick function does, that it's called every frame. I already know that. I don't need a comment to tell me that. I don't need this to tell me when begin play fires or what a constructor does. I already know these things. So in my opinion, that all those comments do is muddy up your code. I don't need them. I want comments where they make sense, where there's some complex code that isn't obvious to you from just reading. I'll oftentimes create comments, but those comments right there are completely unnecessary. Anyway, so we've got a .h file, we've got a .cpp file. Our .h file is where we declare our class. This is our class definition. So when we want to create variables and functions, we define them here in our header file. Our C++ file, CPP file, is where our actual code goes that does things. So all of the functions that you define here, you're going to actually implement in this CPP file. So to create the same thing we did in the blueprint, I need two things. One is I know that I'm going to need a static mesh component, and I don't want that added in the blueprint. I want it added here. So I'm going to create a property, and it's going to be this T object PTR class. Basically, and I mistyped that 1 second. That needs to be capital. And we're going to do less than U static mesh component greater than. And I'm going to just call it static mesh. So what I've done here is declared a variable of type TObjectPointer that contains a uStatic mesh component. And this is where you need to understand a little bit about generics to understand what's happening there. Basically, the Unreal developers have created this TObjectPointer class as just a wrapper around a pointer to whatever you pass in here. So it's a wrapper around a pointer to a uStatic mesh component in this instance. So I've created that property. Now I want this property to be, I want this property to be editable in the Unreal Engine editor when I create the blueprint that inherits from this. So I need to sort of decorate this property with a macro called uProperty, and I'm going to mark it as edit anywhere blueprint read write. I'm going to give it a category. Badger is fine. And then I'm going to add a fourth parameter here. And you can see Writer already knows what I want to type because I've typed it enough times. It just knows. So I'm going to hit the tab key for it to type it for me. So let me explain this a little bit. What we're doing is we're decorating this property with this macro, and this macro is telling the Unreal Engine how this property should be handled. And I'm saying I want this to be editable anywhere. So basically I'm saying I want the blueprint that I'm going to create from this class to be able to edit this property. If I want to create a blueprint that does something with this mesh, blueprint read write. So this isn't really necessary because I'm not gonna create a blueprint that does something with this property. But I do this anyway because I don't want to have to come back later. If I want to create some blueprint function, I don't want to have to come back later and change this. So I go ahead and make it blueprint read write. I give it a category so I can spot it in the editor, and you'll see that in a minute when I finish this. And this special little property here is saying I've created this property as a private property, so I don't want other classes to be able to modify this property directly. So I've made it private. By default, anything that you create is private. You can see down here I've got this public keyword that's defining this constructor method as public, and then this function's marked protected, this one's marked public. If you don't mark something, it's by default private. So you can imagine it's just like having the private keyword there, but you can see the reason it's gray is because Rider's telling me I don't actually need that because the default is private. So this property is going to be private, but I want the editor to be able to modify this property, and by setting this little tag here, that makes by setting this attribute, that makes it editable through the editor, even though this variable is private. So I'm going to create a second one here. It's going to be float rotate speed, just like I did, and I'm going to default it to 2. So just like I did in the editor for the blueprint, I've created a variable. And I've defined that variable here in my header file. And I also want this property to be editable. So I'm going to mark it with the same exact macro. So now that I've done that, I want to go write code in the tick function that executes every frame that will rotate my object. So down here in the tick, it's already defined for us. I didn't have to type this out because the template, the Rider template, already had this code in it. So I'm going to come down here, and initially I'm going to write this code out more verbose than I normally would, just as a demonstration. There's a rotator object, and just like in here where I got that rotator object from this node, and then I made a rotator object here to pass in to the set actor rotation, I'm going to do the exact same thing. So that rotator object in C code is called F rotator, right? And I'm going to set it equal to this, which is a special keyword I'll explain with a little arrow, get actor rotation. So get actor rotation is a method on the actor class. Since we've inherited from actor, we're able to call it. This is a special pointer that points to the current instance of this object. So you can think of this as sort of the same thing as self up here, right? We're just saying this. You don't have to have the this there, okay? You can just call get actor rotation directly. And I think most people do that, in fact, but I like to type the keyword and get the list of things that are available to me. So get actor rotation. And from that rotator, we need the yaw, just like we grabbed in the blueprint. I'm going to create a little local variable here called new yaw and set it equal to rotator dot yaw plus this rotate speed. And this is effectively the same code as this right here. So now we've got a new yaw. So I need to make a rotator, just like I did in the blueprint. F rotator, new rotator, I'll call it, equals, actually not equals, we'll just create it, and we'll say new rotator dot yaw equals new yaw. And we'll go ahead and initialize the pitch, the pitch to 0 and the roll to 0. And we will take that rotator and we will use it to call this set actor rotation. So So this code now is effectively the exact same code that we have in that blueprint. So talking about this little arrow here a little bit, this is an accessor. So when you're accessing the properties or functions of an object, you use an accessor. So this dot here is also an accessor. So the reason I'm using the arrow here and the dot here is because this object is a pointer, and this new rotator is not a pointer. It's just a regular object. So I'm not going to explain pointers here. I would probably likely do a terrible job of it, but I'm sure there are hundreds of videos on YouTube that can explain how pointers work in C++ and what an accessor is and what a regular object instance is and all of that jazz. Just know here I've declared an object instance that's not a pointer. I could have made it a pointer. I could add the star to it right there to make it a pointer, and at that point I have to use the arrow as my accessor. But it's not how I should do that, because the setActor rotation method is expecting a regular object instance rather than a pointer. So that's a sort of quick and dirty of why I'm using the arrow here and not here. Those are just two different ways of accessing the members of an object, whether it's a regular object instance or it's a pointer. So that's that basic code. Now, back here in the header file, I declared this static mesh component, right? And I need to initialize that to something. My rotate speed is initialized right here in the header file because it's a simple assignment of a number. I don't need to write code in my C++ file for that. But for this static mesh, I do need to initialize it to something. So in the constructor, which, learn about constructors as well. In the constructor, I'm going to initialize this class or that property. So a constructor is basically a method that will fire on your class anytime your class is created somewhere, initialized. So we're going to initialize the static mesh property to a special method that exists, create default sub-object, and you can see that Ryder's already determined exactly what I want to do here. So I'm just going to hit the tab key and it's going to type all that code for me. So we're going to call create default sub-object, which is a method that's available to us because we've inherited from actor. It's a method on the actor object. So actually it's probably a method on the uObject class. You can go looking at the Unreal Engine source code and see that uObject is the base class that everything inherits from. A actor inherits from it, and so it gets this class as a result, or this method as a result. And then since we inherited from actor, we get this method as a result. So we're able to call this. This is going to initialize the static mesh to just be a default sub-object, which is just empty. And then I'm going to go ahead and make this the root object. Set root component, which is again a method available to us because we're on the actor. So actors need a root component, and I'm going to use this static mesh as the root component. We did not do that in the blueprint. In the blueprint, we have a default scene object that then has the static mesh, but I'm not going to worry about creating that. It's pointless for this demonstration. So our static mesh component is going to be our root component. It's initialized to be basically an empty static mesh. I'm going to compile this now, and I'm going to close my Unreal Editor, and I'm going to use, because I like to run my Unreal Editor in a debug session with a debugger attached to it. So I'm going to close my Unreal editor. We'll save that test blueprint. And I'm going to come up here and hit this debug icon. Now, if you're in Visual Studio, I think you just get a green arrow instead and you run it that way. What this is going to do is it's going to compile my code, and then it's going to run the Unreal editor, but it's going to run it with a debugger attached to it. And that will allow me to step in to my code, and I'll demonstrate that. For now, I'm going to hit this button. That's going to start the compiler. We can look at what happens in this build tab. You can see the compiler's running. It's going to compile all of this code, and then it's going to launch the editor in a debug session. Now, I'm going to go ahead and pause the recording because all that's going to take a few minutes. I guess I should mention that's why a lot of people, do that. They're prototyping in blueprints because obviously if you're playing around with your code trying to figure out how you want it to work and you're having to constantly recompile, it gets really annoying really quickly unless you have a super high-end machine. Mine is not super high-end, so every time I compile, I have a wait of a couple of minutes generally. So I'm going to pause now and I'll restart once it's finished. Okay, so my code's compiled and my editor's launched. I'm going to come in here and create another blueprint. Instead of inheriting from actor, I'm going to come down to all classes. And because I've prefixed with Badger, it's easy to find my class, Badger Test Actor. I'm going to inherit from that. And we'll call this BP underscore Badger underscore Test Actor. I'm going to open this blueprint up. And what you'll notice is we already have a static mesh component because we created a property of static mesh component type and we initialized it. So the static mesh component is already there. I don't need to add it. So I can come in, click on that static mesh component, and I can set a mesh. And this time I'll just take the cube. Okay. And if I click on the root here, and I come over here, you can see this Badger category. And again, that's because in the source code, we specified Badger as our category. So we got rotate speed set to 2. I'm actually going to up it to 10 and save. And so you can see how having that property is a huge advantage. If I wanted to change the rotate speed and I didn't have that property, I wanted to go in my source code, edit my source code. If I'd have just let my machine catch up for a second here. If I had just in my C++ file here, if instead of using a rotate speed variable, I had just put the number 2 in here and I wanted to change it, I'd have to come in, change my source code, recompile, wait the 2 or 3 minutes, and then I'd be able to check it again. But by creating a variable instead, I can simply update it here, and that's all I have to do. So I'm going to compile this. Go ahead, save. Like I said, I save a lot. And run. Oh, whoops. I shouldn't have run yet. I haven't actually put this object in the world. I don't know why my machine's doing this today. It's not the best in the world, but it's usually not that slow. Let me dock that and let me come back to my world map. And let's place my cube test actor. Just drop it right there. Hit save. Oh, right. Loads a new map every time. I need to change that in the editor. Alright, let me give that a minute to save. Okay, it's finished saving. So now that it's done, we've got our actor in the world. Let's hit the start button. And there we go. Cube rotating, rotate speed 10. I could actually put the pyramid in there and run that, and you can, once they load up, you'll see they're rotating at two different speeds because I changed the speed on this one to be 10. So that's just sort of a good demonstration of just how close. I mean, I feel like a lot of people don't realize just how close C++ is to doing blueprints. I think, a lot of people are scared away from C++ because I think it's this crazy complicated thing. The reality is the complicated thing here is the Unreal Engine API. And if you know the Unreal Engine API from doing blueprints, I mean, it works the exact same way in C++. So you're already 90% of the way there. Like I said, you just really need to understand the basic syntax of C++, how these files work, how there's a header file and a CPP file and what each one means, how to declare things in the header file, what that syntax looks like, and how to write the basic code in the in your CPP file. And really, this code is no different than the code that's in this blueprint here. It's basically exactly the same. The difference with C++ is we can make this a lot less verbose than I made it here. Really, what I could do is set actor rotation, and I can say F rotator, and then we've got pitch, yaw, and roll, so I can do 0 for pitch. For yaw, I can do this get actor rotation dot yaw, whoops, dot yaw plus this rotate speed comma 0. And actually I screwed that up a little bit. 0, oh whoops, I accidentally put a paren there. There we go. So that one line of code does the exact same thing as this 1, 2, 3, 4, 5, 6, 7 lines of code. You can condense all that code down to one line. And this is where things get sticky with C++. So just like you can write blueprint code that gets all spaghetti looking and ugly if you're not careful, you can write C++ code that gets hard to read if you're not careful. This, condensing this into one line, in my opinion, this is not hard to read. It's probably at about the limit of what I would do, though. If I needed to do much more, I probably would break it out into multiple lines. When you condense things, they can become a little bit unreadable, and you can see how this is certainly not quite as easy to read as this down here. Instead of creating a rotator and then adding the yaw in, I just create the rotator right here and pass it directly in, doing the math as part of my constructor here. This is a little bit more complicated to read, and like I said, it's probably about the limit of what I would do in one line of code. You can write some really ugly C++ code, just like you can write some really ugly Blueprint code. So it's on you to decide, what kind of code you want to write. The only thing I would mention, so I've shown some basic C++ syntax here. I would learn branching logic. So the if statement, just like there's branching logic in a Blueprint, you can write an if statement. If, get actor rotation dot yaw is greater than 180, and you can write some special code here. So I would learn this syntax for how to write if statements, how to write an else statement. I would learn loops, in particular for loops. So for int I equals 0, I is less than 100, I plus plus. This is an old style for loop. There we go. I is less than 100, I plus plus. So this will loop 100 times. So any code I put inside here is going to get called 100 times. That's a very basic for loop. They're going to get a lot more complex later on. But really, for loops, if logic, maybe switch statements. You can switch on a yaw. I don't know why you would ever do this, but you could switch on yaw case 0. So if the yaw is 0, do this. If it's 1, do this. If it's 2, so on and so forth. That's a switch case statement. I would learn those. But really, if you understand those basic syntax, classes, properties, functions, and then basic branching logic and for loops, you're gonna know 99% of what you need to know. So I'm going to make a basic RPG here, and as I go, I'll try to explain everything I'm doing in C++ really well, and maybe sometimes even show the blueprint that I'm, doing something in a blueprint first and then putting it in C++ later when you're ready. Anyway, I think this is where I'm going to stop this video. I just wanted to show this very basic C++. I'm actually going to get rid of this test actor, everything I created before we start in on the actual RPG or whatever it is I'm building here. So anyway, that'll be it for this video, and in the next video I'll bring in some assets and start actually creating something a little bit more real. Until then, take care.